Today we're going to talk about sectors and arcs. So let's talk about the area and circumference of a circle. The area of a circle we know is pi r squared, and r would be our radius, so this piece right here. And it's super important to remember that that radius starts in the center and it can go to any point on this circle. So if we have a radius, it's kind of like the hands of a clock. The clock hand length is not going to change, but it's going to remain the same distance as it goes all the way around. The circumference, we can say pi diameter if we want to. So our pi diameter would give us this entire length from an end of the circle through the center to the other side of the circle. Or we have 2 pi r, because we know that the radius is half of the diameter, so if we multiply that. So if we look at this picture here, just a regular circle, we've done this before, what is the area of this circle? So we work this out. We know we need to use area equals pi r squared, pi times the radius of this circle squared. We know our radius is 11, so we plug that in. Don't forget to put your parentheses around your 11. We will just want to make sure we do that, and then we can square that 11 and we get pi times 121. Now if we are looking at pi times 121, we call this in terms of pi. We would say 121 times pi inches squared, or squared inches, and that would be in terms of pi. So if you ever see a question that's talking about leave it in terms of pi, we want to keep the pi. We don't actually want to multiply it, so that we can have a prettier number and we don't have to do any rounding. But we can also go ahead and multiply that out, and if we do that here, we get 379.94 square inches for this entire circle. But what if we only wanted part of this circle? So let's say we only wanted this little section within here. So we have a quarter of this circle, and we know it's a quarter because of this right angle right here. So I want to find this here. I have that right angle. I know that there are 360 degrees total in a circle. And if I have 94 times, so if I have 4 sections with 90-degree angles in there, we've got our entire 360 degrees. But I only want to find a portion of it. So what we can do is we can take our answer from here and we can split it into 4 equal pieces. So 379.94 roughly divided by 4 is about going to give us about 95 square inches. And we aren't always going to know that perfect number. We don't always have them split into 4 equal pieces. But when we do have them split, a circle split into pieces, we are going to call that a sector. So the area of a portion of a circle, the area. What if I want to find the area of a sector that I don't know is just a quarter? So maybe I don't know how much 45 degrees is of 360 degrees. I don't know what that fraction is. Is there a way that we can still work this out? So I want to find the area of this 45 degree sector within a circle that is carrying a 4 centimeter radius. Well, if we say 45 divided by 360, we know we can get that ratio of how many degrees out of 360, what fraction of the pi that we have. And that's going to come out to be 1/8. So we can do the same thing. We can find the area of this circle, which is pi r squared. We can work it out. We can plug in our 4 centimeter radius, and we can square that radius and get pi times 16. Now again, if our question said to put this into terms of pi, our answer would end up being 16 pi square centimeters. But we're going to go ahead and bring it down into a decimal, so we get about 50.24 square centimeters. But I don't want that entire circle, so this right here is the entire circle. We only want 1/8 of it. So we can multiply or divide by 8. So we can multiply 1/8 times 50.24, the entire circle, and that will give us 6.28 square centimeters. So can we write a formula for this area of a sector? Well, in the previous question, we said that we could take that 45 degrees and divide it by 360 to find out what portion of the circle we were actually looking at. And then we ended up multiplying it, or taking that number and dividing our final whole circle. So if we write a formula, we can say that the degree of a sector divided by 360 is going to be multiplied by the area of a circle, of the whole circle, and we will end up with that area of that small piece. So we take the degree of the sector, or of the piece of this circle that we are looking for, we divide it by 360, and then we multiply it by the area. Now we also have things that are called arcs. So when we're talking about arcs, we're talking about the circumference of the circle. So arcs are the circumference of the circle. They're very similar to the same way that we find our areas of sectors. So we're going to look at this 225 degree piece. We want the distance from this side of the circle to this side of the circle. So we can do the same exact thing that we did before. We can say that we have 225 degrees over 360, because that's how many degrees we're looking at over our total amount of degrees in a circle. And we multiply it this time by circumference. So you can use 2 pi r, or you can use pi diameter if you want to just multiply that in your head. If we simplify 225 over 360, that's going to give us 5 over 8. Now if you're using a calculator, it's not really necessary to do that in a separate step. But this right here is 5/8 worth of our entire circle. So we multiply 5/8 times 2 times 15, our radius, and we get 5/8 times 30 pi. Then if we multiply that out, including the pi, we'll get 58.875 square miles is the distance of this 225 degree arc. So we can also write a formula for that, and it's going to look very, very similar. We're going to use the degree of the sector divided by 360, so the part we want, out of the whole piece of the 360. And then we can multiply it this time by circumference. So it's just going to matter whether you're looking at the area of this circle, or the small piece of this circle's area, or you're looking at a small piece of this circle's circumference. So if you're looking at the circumference, we would multiply by circumference. If you're looking at area, we would multiply by area.